Hey everyone, this is Pamni Sen, and today I'll be discussing about the topic so-called distributions. Okay, it's nothing but the unit number 4. As I already told you, this distributions allows you to understand how the data is spread. Okay, so fine. Let's come back to those. How many distributions are there, and what are those, and what are the formulas for it? Okay, this is just a gist of the concept, so I want you to just understand this, and after that you're going to go through that answers which are in the PDF. All right. So and coming to the distributions, there are two types of distribution. One is discrete, one is continuous. Discrete means the one which you can count. Okay. And continuous is nothing but suppose from, if you take 500 milliliters of water, so you will range, how the range will be from 0 to 500, isn't it? Can you count how many drops of water droplets are there inside the water? No, right? So it's a continuous thing. So that's a continuous. Just remember this. Discrete is where you can count. Continuous is which can you count, cannot count, but basically it will be in the decimal format, something like 3.4, 5.5, something like that. Okay. So there are two type of distributions, and the distributions are divided, and also in those distributions also you have so many types. Okay. So we'll be discussing about Bernoulli's distribution, binomial distribution, normal distribution, Poisson distribution, exponential distribution, multinomial distribution, and beta distributions, beta binomial distributions, anti-distributions, and uniform distributions. Okay, so here, so let's come back to the Bernoulli distribution. Okay, what is this Bernoulli distribution is all about? Suppose you are flipping a coin. Okay, so what is the outcome you will get? Either heads or else you will get tails, isn't it? Either success, if you, if you write a question in an exam, either correct or else wrong, isn't it? Any one output you will get, right? If you roll a dice, either you will get one or two or three or four or five or six, isn't it? So something like that. So you will get outcomes. Okay. So just remember one thing, in Bernoulli's, whenever you are going to give a trial, what is a trial again? Trial is something that you're just doing in an experiment. Okay. So whenever I'm flipping a coin, that's a trial. If I'm doing with one time, it's one trial. If I'm doing second flip is second trial. Okay. So in Bernoulli, what happens is there will be only two outcomes. One is success, one is failure. That too, for each trial. In a single trial, you will get only outcomes. What is that outcomes? Two possible outcomes. One is success or one is failure. Okay. So that is called Bernoulli distribution. I hope you understood it. Now we'll come back to the binomial distributions. Binomial distributions are nothing but, here everything has a probability. Okay. So what do you mean by everything has a probability? Suppose you are flipping, suppose you are writing an examination. Okay, so in that exam, what happens? There are multiple choice questions, isn't it? For each question you should answer suppose there are internal examinations. What happens in the internal? You have multiple choice. Each question, either you will do correct, either you will do wrong, right? So like that, if I give you MSET exam, there will be some sort of, like, suppose there are 1,000 questions. For each question, either you will get, it's each question is a Bernoulli trial. Do you agree with me? Because either you will be correct or else you will be wrong. And all together, what is a pass mark? 35, right? So all Bernoulli trials, overall results will follow binomial. That means based on the pass percentage, if you are getting more than 35 or 35, you will be pass, or else you will be failed. Okay. So here binomial distribution determines that pass or fail rates in examinations. That means in a multiple choice exam, each question can be considered as a Bernoulli trial. Why Bernoulli trial? Because each question has either pass or else, either correct or wrong. All together will follow binomial distribution. So binomial, bi means two. Okay, either you will pass, either you will fail. Okay, So it depends on number of trials. Either you will the probability, and also it depends on the probability of success. Mostly you will do it in the science lab. Suppose you are doing COVID-19 vaccine test. So you will take the patients and then you will test on them. So like that, on how many patients you will do, so that the success of the coronavirus is just reducing. Okay. On each person you're doing, either it will be success or else failure. Only two outcomes. No, that is Bernoulli trial. But with each person you're doing like that, you're doing with 100 people. How do you determine the pass percentage? If you're doing with 65 people, if 65 people are sustaining in the life and 35 are dying, then you will say that your vaccine is success. So this thing you will consider as binomial distribution. Now let's talk about normal distribution. Normal distribution is nothing but it will be like bell shape. That means it is normalized. The data is normalized, and basically it will be characterized by two things. One is mean, one is standard deviation. Standard deviation is always represented by sigma. Okay, this is called, the symbol is called sigma. So it is used in various fields, especially in statistics. You will use to understand how the data is spread, is it normal or not. So basically we'll use it in the statistical inference. And what is the example of this? So let's understand the heights of an individual in a population. Often, like, what is the average human height? All for girls it's almost like 5.4 to 5.5, right? So that means mostly the human heights are falling under that range around 5.4. That's the reason you're saying that, okay, the mean of that particular thing is like 5.4, right? So human heights often follows the normal distribution. That means most of the people clustering around the average height, most of the people will fall under that, right? Now let's talk about Poisson distribution. Poisson distribution is very easy. That means the events are occurring, that too in a fixed interval of time. Okay, so suppose I'm taking from 6 o'clock in the morning to 6 o'clock in the evening. How many calls I'm getting in the suppose I'm running a company which is customer care. How many calls are coming in Monday? How many calls are coming on Saturday? And also in the evening hours, how many calls are coming? And also in the morning hours, how many calls are coming? Okay, so in a fixed interval of time, so you will find the occurrence of an event. That is what Poisson distribution is. Okay, so it's employed in risk analysis, predicting occurrences within the specific time period or spaces. Now, let's understand like number of phone calls you will receive by a customer call in an hour. The number of calls a call center is receiving in a fixed interval of time. This type of problems you will just do which distribution? Poisson distribution. That too with rare but frequent events will occur. Exponential distribution. Exponential distribution is nothing but what is the time duration before an event occurs. Suppose you're using any shampoo. Okay, within which time we can just use that shampoo? You're using some sort of chips. Within which time, within which time, within the which expiry date you will just use it? What is the time period? So that is what it is. So this distribution always follows the time duration before an event occurs. It's commonly used in survival analysis. You will predict the lifetime of the products. Okay, and also what is the duration between each event. So that is what exponential is. So time between arrivals of buses at a bus stop. The time between successive arrivals of buses often follows an exponential distribution. Okay. Next is all about multinomial. Multinomial is something where you will use a lot of variables in it. Okay. So the multinomial distribution measures outcomes of the experiments with two or more variables. Okay. And it basically follows binomial distribution, and it finds application in various fields like biology, geology, and finance. You will use that. Next, all about like if you roll a die, which is like six faced multiple times, what is the occurrence of like one happening? What is the occurrence of two happening? What is the occurrence of three happening? What is the occurrence of four? What is the occurrence of five? What is the occurrence of getting six? So all these like multi variables, right? I'm getting a lot of variables. I'm relying on it. The outcomes are relied on it. So that is what multinomial is. Next is all about beta distribution. What is beta distribution? It's nothing but a continuous probability distribution. What is continuous probability distribution? It's nothing but you will get it's not, I already really like discrete continuous, you already know it. So and the continuous they all actually have a shape parameters, which is they always follows two parameters. One is alpha and the one is beta. It is used for basically getting the percentages and proportions. So you will just actually find out like uncertain success probabilities depicting random behavior. Here, beta distribution of proportions in a population, the population of voters in favor of a political candidate, or the proportion of defective items in a batch of products. So it's uncertain, right? Uncertain success probabilities. Otherwise, depicting random behavior. Depicting random behavior like defective pieces in a batch of products. And also, what did they say? Uncertain success probabilities, like how many voters are in favor of a political candidate. Okay, it's uncertain. And also, like we didn't predict that Congress will be taking up the government, right? It's like uncertain. So, how many voters are in the favor? Like, what are the basically, what are the like minus points? Because it was a government didn't take up the well regarding the employees. So that's the reason, that's the downfall of most of the TRS party, right? Okay, let's not talk about it. Next is beta binomial distribution. So it always combines the beta distributions as well as binomial distributions. So Bayesian models are used, and also it is mainly used in marketing and epidemiology. It is not a very big deal of like everyday example due to its very complexity. Next is our T distribution is also known as students T distribution. It is used to estimate population parameters with small sample size and unknown standard deviations. It's crucial for hypothesis testing and constructing confidence interval. The distribution of sample means when the population standard deviation is unknown, often for if you don't know the standard deviation, so you will find out how the mean is getting distributed. Okay, so that is why it will follow the T distributions. Next is all about uniform distribution. The uniform distribution features equally likely outcomes in either discrete or continuous form. All the events have the same probability of occurring. Example, if you roll a dice, it might be six, it might, and every number has an equal probability, or selecting a random number within the range. So random number uniform distribution is like random number generation. When selecting a random number between two values, a uniform distribution is used to ensure each outcome has an equal probability. Uniform as nothing but equal. Okay, let's move on to this uh, the formulas. So Bernoulli is nothing but f of x is equals to f of x is nothing but PDF, probability density functions. So it's a mathematical formula. So what is the formula? P power x into 1 minus p power 1 minus x. X is nothing but the outcome. Either you will get failure or else success. The binomial distribution is nx p power x into 1 minus p into the power of n minus x. Okay. Here x is nothing but the how many successes are happening in it. N trials, what is the probability of success is happening in each trial? Okay. Normal Gaussian distribution is nothing but f of x is equals to 1 by under root of 2 pi sigma into e power minus x minus mu whole square by 2 sigma square. Here sigma is nothing but standard deviation and x is nothing but the value of the random variable. E is nothing but the base of the natural logarithm. Okay, it's a logarithmic function. Poisson distribution f of x equals to e power minus lambda into lambda power x by x factorial. Exponential distribution is equals to f of x equals to lambda into e power minus lambda x. Multinomial is equals to, but there are different variables, right? Here I'm taking x, here I'm taking p, here these are number of trials. Okay, so n factorial by x1 factorial, x2 factorial, so on up to k factorial into p1 to the power of x1 into p2 to the power of x2, so on to pk to the power of x power k. Beta distribution is nothing but f of x is equals to x power alpha minus 1 into 1 minus x to the power of beta minus 1 by b comma b of alpha comma beta. So alpha comma beta are the beta functions. Beta binomial is not easily due to its complexity, and also it is not represented T distribution also. But uniform is equally likely events. So f of x equals to 1 minus b minus a, where a and b are the endpoints of the interval. Thank you so much for listening. Bye bye.